All right, guys, so I know we do have a shortened schedule today and shortened class today, but what we're going to do is we're going to cover two more of the Descartes rule of signs, and then we are actually done with 4.6 and chapter 4. Now, Descartes' rule of signs tells us the number of possible positive zeros and the possible number of negative zeros that a polynomial function can have. So if we look at this here, nope, come back. Okay, well, missing assignment. Yep, so that's the review sheet, and you do need your missing assignment sheet. So, for the possible number of positive zeros, we count the sign changes for the function itself. So from x to the 6th to x to the 5th, it goes from positive to negative, so that would be 1. X to the 5th to x to the 4th, it's going from negative to negative, so we can't count that. X to the 4th to x cubed goes from negative to positive, so that'd be 2. Then we have positive to positive, so we won't count that. Positive to positive, and lastly, positive to negative would be 3. Now this one and the last one both had 3 as the number of possible positive zeros. Doesn't have to be 3. We just count the number of sign changes, and that tells us the number of positive solutions that it will have, or less than it by an even amount. So we could say 3 minus 2 is 1, and if we try to subtract 2 again, we get negative 1, so that doesn't work. So 3 and 1 are the only possible positive zeros that we can have. Now to find the negative, we're going to take f of negative x. Now one of the biggest things I pointed out with the negatives yesterday, if the exponent is even, the sign stays the same. If the exponent is odd, the sign changes because that negative comes out. Because we multiply negative by itself an even number of times, it becomes positive. Odd number of times, it's going to be negative. So that tells us with 2x to the 6th, because the 6 is an even exponent, it's going to be positive, which means the sign in front of our 2 won't change from positive to negative. So it just stays 2x to the 6th. Negative 5x to the 5th, because that x to the 5th is an odd exponent, it means that negative is going to come out, changing the sign with the negative 5 to make it positive 5. Questions on this here? Our next one is negative 3x to the 4th, because the exponent's even, the sign stays the same. Our next one, the exponent is odd, so the sign is going to have to change from positive to negative. 10x squared, because the exponent is even, the 10 is going to stay positive. Plus x, exponent's odd, so it's going to change, and our 9 doesn't have a variable, so it just is just going to be minus 9. So if the exponent's even, the sign stays the same. If the exponent's odd, flip the sign. Then count the sign changes. Positive to positive. Positive, negative would be 1. Negative, negative doesn't count. Negative to positive would be 2. 3. So our negatives would be 3 and 1 also. Any questions on how we found the total number of positive and negative zeros? Now, when we set the table up, really what we're doing is finding all the possible combinations of the 3 and 1 for positives and the 3 and 1 with negatives. And we get the complex with what's left over from the total. Since it is a degree 6, we should have a total of 6 solutions. I always start with the most of each. So 3 positives, 3 negatives. That does give me a total of 6. So I'm not missing any from my total number of solutions. 3 positive, 3 negative, we have a total of 6. The degree tells us we should have 6 solutions, so they're all there. Now the next possible arrangement is I can have 3 positives and 1 negative. which is a total of 4, and because we need 6 solutions, it means the other 2 have to be complex. Because again, we have to have a total of 6. Now we've done every possible arrangement with 3 positives and our negatives, but we can also have 1 positive and 3 negatives, which is still a total of 4. We need it to be 6, so the other 2 have to be complex. And lastly, we could have 1 positive, 1 negative, and 4 complex. And that is the only arrangements of these here. And that's our answer. Now, all the values that we can have for the complex have to be in even number. All of our complex numbers in that column have to be even. And that's not just something I'm saying. It's because, again, when we talked about the complex conjugate theorem, if A plus BI is a solution, A minus BI is a solution, they always come in pairs. I can't just have 1 complex solution. We have to have 2. So the complex column has to be an even number, since they're always coming in pairs. Questions on this here? Last one, let's look at this one. We're going to look at number 9 last. This is the last problem we're going to look at with these here. And as we look at this here, we have x cubed plus 9x minus 25. With synthetic division and long division, if we are missing a term, we filled it back in. Here, we're missing x squared term. For Descartes' rule of signs, we do not have to put it back in. We don't have to add those terms, those missing terms back in. With synthetic division and long division, yes, we need to fill those back in. Here, positive zeros, I just count the sign changes from one to the next. X cubed to x, there was no sign change. X to 25, there was 1, telling me that my number of positive zeros is 1. Yes. Or less than it by an even amount. Well, if I do 1 minus 2, I get negative 1. So I have only 1 possible arrangement for positives. There is just 1. Now for our negatives, f of negative x. We replace every x in f of x with negative x. And when we do that, we can just look at the exponent. If the exponent's odd, we change the sign. Well, x to the third would be a negative exponent. Not negative exponent, odd exponent. So we'd flip the signs. It was positive, it's now negative. Our next one's positive 9x. X is written, it's not written to the first, but it's understood to be, which is an odd power, so we change it from positive to negative. 25 does not have a variable, so we don't do anything with it. And the number of sign changes for negatives is 0. It did not change it. Negative, negative, negative. So setting this table up is actually kind of nice. Well, the most number of positives I can have is 1. The most number of negatives we can have is 0. So what's our total right now for positive and negatives? 1. How many solutions should we have? 3, because the degree is 3, yes? So how many complex solutions should we have for this? 2, because this total, as we add these across, should equal the degree, should equal the total number of solutions, which is 3. So if we were solving this here, it's telling me I'm going to have 1 positive solution. It's going to cross the x-axis at only 1 point. The other 2 are complex. That is the only way this is solved, as with these here. Questions on Descartes' rule of signs. And really, that is it. That is it for chapter 4. There are other parts and other things we can do, but we're out of time. So you have the rest of the class time to work on the assignment for 4-6, as well as any other assignments that you are missing. If you want to grab a review sheet, you can. We're going to start going over it on Monday. If we finish the review sheet Monday, We're going to test Tuesday, Wednesday. If we don't, we'll test Thursday or Wednesday, Thursday. There are 24 or 25 problems. It is cut into 2 parts. If you do feel very confident with it, you can easily finish those up. But this is the last test. All homework is due end of the day Friday, which again, we'll have another shortened Friday next week.
Are we going to have enough time to make points on the test next week? Okay.
But I would not plan on doing it. I would study and get ready and do well on the test.